We will now be solving question number 6 to 10 from exercise 11.4, which is from chapter 11 on the topics of surface areas and volumes. So let us first do question number 6. A hemispherical tank is made up of an iron sheet 1 centimeter thick. If the inner radius is 1 meter, find the volume of the iron used to make the tank. So what is given to us and what is it that we have to find here? We are given that the inner radius of this hemispherical tank is 1 meter. The thickness of the iron sheet used is 1 centimeter. And we are asked to find the volume of the iron used, which is nothing but the volume of the material which is between the inner surface and the outer surface. So we have to find the volume of all this material that is used in making this particular tank. So it is all this area here. So how can we proceed with solving this particular problem? How can we calculate the volume of the iron that is used in making this hemispherical tank? So let us first write down what is given to us. So we'll write here given is the inner radius as 1 meter. We are also given the thickness as 1 centimeter. We'll convert that centimeter to meter, so we'll have it as 0.01 meter. And from this we can now calculate the outer radius. Outer radius will be inner radius plus the thickness. Let me write that clearly. So the outer radius is the inner radius plus the thickness, which will be 1 plus 0.01, and that will be 1.01 meters. Okay, so the inner radius is 1 meter, the thickness is 0.01 meter, so therefore the outer radius is going to be 1.01 meter. Now what is it that we have to calculate? I'm going to split the page into two parts here. So okay, so we want to calculate the volume between the outer surface and the inner surface. So that means we have to calculate the difference between the outer volume and the inner volume. So the volume of the iron used is going to be the outer volume minus the inner volume. So effectively we are going to calculate the volume of the material used, which is going to be the outer volume minus the inner volume. So the outer volume, we have to calculate the outer volume of the hemisphere, which will be 2 by 3 pi r cube, and the r used here will be the outer radius. So that's 2 by 3 pi r cube, and the outer radius we'll call it with the letter capital R. We'll denote that as capital R. So I've written here capital R is the outer radius. And so we can write the volume for the outer part, that is the outer volume, as 2 by 3 pi r cube, and minus the inner volume, which is minus the inner volume. The volume of the hemisphere is again 2 by 3 pi r cube, and we'll call the radius of the inner part as small r. So let's denote the inner radius by a small r. So the inner radius, we'll call it a small r, and we'll call this as 2 by 3 pi r cube with a small r. So now we have to calculate this difference, and that will give us the volume of the iron that is used in making this hemispherical tank. So now from this we can see that we can take the 2 by 3 and pi outside as common factors. So we'll have 2 by 3 and pi, which is 22/7, as common factors into the outer radius cube minus the inner radius cube, and that is what is our calculation. So it's 2 by 3 into 22 by 7. The outer radius we have as 1.01 meter, so it's 1.01 cube, minus the inner radius is 1 meter, so it's 1 cube. So now we can solve this and get the answer for the volume of the iron used in making the hemispherical tank. So we'll have it as 44 by 21. So that's 2 into 22 is 44 and 3 into 7 is 21. So we have this 44 by 21 into 1.01 cube minus 1 cube. So 1.01 cube is 1.0303 minus 1. 1 cube is 1. So we'll have this as 44 by 21 into 0.0303 0.0303. So once we multiply these numbers, we will get the desired volume for the iron used in making this hemispherical tank, which happens to be 0.06348 meter cube. 348 meter cube. Okay, so that's the answer for the volume of the iron used to make the hemispherical tank. Okay, and that is what we have to do here. So basically the way to approach this problem is to take the difference between the outer volume and the inner volume. That gives us the volume of the material used to make this hemispherical tank. Okay, so because it's a hemisphere, we have used the formula for the volume of the hemisphere, which is 2 by 3 pi r cube, and for the outer volume we use the radius of the outer part, which is the outer radius, and for the inner volume we use the inner radius, which we have denoted by different letters and substituted the appropriate values. So the outer radius, which we denoted as capital R, is having a value of 1.01 meter, and the inner radius, which we have denoted as small r, is having a value of 1 meter. So we just substitute that in the formula for the volumes and simplify the expression, and we get our answer for the volume of the iron used to make the hemispherical tank. So now let's move on to the next question, question number 7 from this exercise 11.4. So here we are given the surface area of a sphere as 154 centimeters square, and we are asked to find the volume of the sphere. So from the surface area, so what is given to us is surface area. Let's write that down. Surface area equals 154 centimeters square. The formula for the surface area of a sphere is 4 pi r square. Then that equals 154 centimeters square. So from this we will be able to compute the value of r. So what will be r square now? R square, let me write down all the values here. 4 into pi is 22 upon 7 into r square is equal to 154 centimeters square. So we can now simplify this to find the value of r square. So r square will be 154 into, we take the 7 to the other side, it goes to the numerator, and then we have the 4 and 22 coming to the other side in the denominator. So that's 4 into 22, and we can simplify this and we get the value for r square. So we clearly see that we can cancel out this 22 with this 154, because 22 goes into 154 7 times. So we end up getting 7 into 7 divided by 4. So that's 7 into 7 divided by 4. And we can write that slightly differently because we need to calculate the square root in the end. So 7 into 7, and the 4 we can split it as 2 into 2. So that's the value of our r square. So therefore we can find now the value of r as the square root of 7 into 7 divided by 2 into 2. So that will simply be 7 divided by 2. So when we are taking the square root, whatever appears in pairs, we can take it out of the root and put it only one time, right? We have seen these calculations before as well. So we get the value of the radius as 7 by 2, which is basically 3.5 centimeters, because the surface area is given in terms of centimeter square. Therefore, the radius is going to be 7 by 2 centimeter. So now that we have the value of the radius, we can calculate the volume of the sphere by applying the formula for the volume. So what is the formula for the volume? Volume of sphere is 4 by 3 pi r cube. So we now have the value of r with us, which we have obtained by using the surface area. So 4 by 3 pi is 22 upon 7 into r cube is 7 by 2 into 7 by 2 into 7 by 2 is r cube. So we can now simplify this and we will have the answer for the volume of the sphere. So we can have one of the 7 cancelling out with the 7 in the denominator here. The 2 goes into 22 11 times, and one of the other 2's, this is 2 and 2, that's 4, so that will cancel out with the 4. So we are left with the remaining numbers, which is 11 into 49, so that's 11, and 7 into 7 is 49, so that's 11 into 49 divided by 3, and that gives us the volume of the sphere. So 49 into 11 divided by 3 is 539 divided by 3, 539 divided by 3, which is equal to 179.667 centimeter cube. Okay, so we now have the volume of the sphere. So the radius was not given to us in the question directly, but the information to calculate the radius was provided in terms of the surface area. So by applying the formula for the surface area and using the value of the surface area given to us, we were able to calculate the value of the radius. And once we had the value for the radius, we were able to substitute that in the formula for the volume of the sphere and calculate the volume of the sphere, and we obtained the answer as 179.667 centimeter cube. Let's move on to the next question now. Question number 8 of this exercise. We are given a dome of a building is in the form of a hemisphere. From inside it was whitewashed meaning it was painted at the cost of rupees 4,989.60. If the cost of whitewashing per square meter is rupees 20, we have to find what is the inside surface area of the dome, and then find the volume of the air inside the dome. That is basically the volume of the hemispherical dome. So how can we proceed in finding the inside surface area? So we have the total cost of painting, which is 4989.6, and we're also given the cost of painting per square meter. So dividing the total cost by the cost of painting per square meter, that should give us the inside surface area of the dome. So solution for part 1 is let's call it inside surface area. Inside surface area equals total cost of whitewashing by the cost of whitewashing per square meter. So that's the total cost of whitewashing divided by cost of whitewashing per square meter. So we know what is the total cost of whitewashing, that is 4989.60 divided by the cost of whitewashing per square meter is rupees 20. So we have divided by 20, and when we divide this, we get the answer as 249.48 meters square. 249.48 248 meters square, and that's the value for the inside surface area of the hemispherical dome. Now, from the inside surface area of the hemispherical dome, we can calculate its radius. So the inside surface area is nothing but the surface area of the hemisphere. So therefore, we can write inside surface area. Let me write that clearly. Inside surface area, which is given as 2 pi r square, is equal to 249.48 meters square. So from this we will be now able to calculate what is the value of r. So let's substitute that. 2 pi r square is 249.48. So that's 2 into 22 upon 7 into r square is 249.48. So we can now obtain the value of r square. So r square will be, we'll take all the other terms to the other side of the equal sign. So it will be 249.48. When we take the 7 to the other side, it goes to the numerator, and the 2 and 22 will come to the denominator. That's 2 into 22 in the denominator, and we will simplify this to get the value of r square, which happens to be 3969 divided by 100. So that is 3969 divided by 100. Okay, so let me just do the steps for this, just to be clear for you. So this r square, let me draw a line here. Let me make a partition here so you can show the calculations in a clearer way. So the r square value, so r square is, just to get rid of the decimals, I'm going to multiply the numerator and denominator by 100. So 249.48 into 100. So we can move the points, the decimal 2 places to the right. So I multiplied the numerator by 100 into 7 by 2 into 22 into 100. So I'm just going to multiply the denominator also by 100. So multiplying the numerator with 100, we have 249.48. The 2 decimal points are shifted to the right, and we get 24948. And we also have 100 multiplied in the denominator. So that does not change our expression. We have done this just to get rid of the decimal point in our calculation. So now when we perform this calculation and simplify, so there is a 2 here and a 22 here, which goes into 24948. We can simplify this, and we will have the value as 3969 divided by 100. So that is how we get 3969 divided by 100. So again, I'm just going to simplify it for the sake of clarity for the students. So the 2 here goes into this 1, 2, 4, 7, 4 times, and then we can have the 22 going into 1, 2, 4, 7, 4. How many times? When we divide 1, 2, 4, 7, 4 by 22, we will get 567. So 567 into 7 is 3969, and then we have the 100 in the denominator, so we get 3969 by 100. Now the 3969 divided by 100 is equal to the square of the radius, so that's equal to r square. So we can write this 3969 divided by 100 as 3969 is nothing but the square of 63. So that's 63 into 63 divided by 100 is the square of 10, so that's 10 into 10. So r square is 63 into 63 divided by 10 into 10. So therefore we can write r as the square root of that. So it's square root of 63 into 63 divided by 10 into 10. So that will give us, again, when we take the square roots, when we have some number appearing twice in a product inside the square root, we can take it outside as only once. So we'll simply get 63 divided by 10. So 63 divided by 10, which is basically 6.3 meters. Okay, so that gives us the radius of the hemispherical dome. Okay, so we now have the radius of the dome. From the radius, we can now calculate the volume of the hemispherical dome, which is going to be the volume of the air inside the dome. So for the second part of the question, we have to basically compute the volume of the hemispherical dome. So volume of hemispherical dome, and we use the formula for the volume of a hemisphere, which is 2 by 3 pi r cube. So that's going to be 2 by 3 into pi is 22 over 7 into the value of r. We have obtained the value of r as 6.3, so that's going to be into 6.3 into 6.3 into 6.3, and we basically are going to simplify this. So 3, let me use a different color here. So 3 will go into 6.3 2.1 times. So then we can have the 7 going into this 2.1 0.3 times. So we now have 2 into 22. So what is left is 2 into 22 into 6.3 into 6.3 into 0.3, and when we multiply these numbers, that gives us the volume of the air inside the hemispherical dome, which turns out to be 523.9 meter cube. Okay, so 2 into 22 into 6.3 into 6.3 into 0.3, that gives us 523.9 meter cube, which is the volume of the air inside the dome. So therefore we will write volume of the air inside the hemispherical dome is 523.9 meter cube. Okay, so we have now obtained the volume of the hemispherical dome as well. Again, in this particular question, the radius of the dome is not given to us directly, so we had to first calculate the inside surface area by using our basic knowledge of dividing the total cost by the cost of whitewashing per square meter to obtain the inside surface area. And once we had the inside surface area, we substituted the formula for the surface area of a hemisphere to obtain the value of the radius from the inside surface area. And once we had the radius, we were able to use the value of the radius in calculating the volume of the hemispherical dome by using the formula for the volume of a hemisphere, which is 2 by 3 pi r cube, and we obtained our answer as 523.9 meter cube. Okay, now we can proceed to the next question, question number 9 from this exercise. This question states that there are 27 solid iron spheres. Each has a radius of some r, and the surface area of each of the solid spheres is capital S. And all these 27 solid spheres are melted to form a single sphere with some surface area, which is denoted as S dash. We are asked to find the radius r dash of the new sphere, and then the ratio of the surface area of the small sphere to the surface area of the single large sphere. So we have to first understand that 27 spheres are being melted and made into one single big sphere. So that means the volume of the 27 spheres must be equal to the volume of the single large sphere that you are making. So we have to equate the volume of the 27 small spheres with the volume of the single large sphere, and using this equation we will be able to find a relationship between the radius of the small sphere, which is r, and the radius of the large sphere, which is r dash. So the first thing we need to understand is the volume of 27 small spheres is going to be equal to the volume of the single large sphere. So let's write that down. So we have here that the volume of the single large sphere is equal to the volume of all the 27 small spheres, and that is basically the same thing as saying that 27 times the volume of each small sphere, because all the small spheres are having the same radius r, so therefore it is 27 times the volume of each small sphere. Okay, so now we have a relationship between the volume of the single large sphere and the volume of each of the small spheres. So now we can use the formula for the volume by using the appropriate radius for each of the spheres. So we are given in the question that the radius of the small sphere is small r and the radius of the large sphere is r dash. So we will use that in our expressions for the volumes. So radius of large sphere is r dash and the radius of each small sphere is r. So we will use this in our equation for equating the volumes. So the volume of a sphere is 4 by 3 pi r cube. Therefore for the large sphere it is going to be 4 by 3 pi the radius of the large sphere is r dash, so it's going to be r dash cube, and that is equal to 27 times the volume of each of the small spheres, so which is 4 by 3 pi into the radius cube, where the radius will be for the small sphere, which is denoted by r, so that is r cube. Okay, so we have now the expression for the relationship between the volume of the single large sphere and the volumes of the 27 small spheres. Now there are certain common terms on both sides of the equal sign which can be cancelled out. So we have the 4 by 3 here and the 4 by 3 here will cancel out. The pi and pi on both sides will cancel out. So basically we're going to have r dash cube as 27 times r cube. So basically we'll write this as r dash cube is 27 times r cube, but we know that 27 is 3 cube. 3 into 3 into 3 is 27, so we can write this as 3 into 3 into 3, so that's 27 r cube. So 3 into 3 into 3 is nothing but 3 cube, so that is 3 cube r cube. So we can write that as, let me write that in the same line so I can have some space here. So that will be 3 cube times r cube, or in other words we can write this as 3r the whole cube. Okay, so we're just simplifying that expression. So we have the relationship now between r dash and r. So r dash cube is equal to 3r cube. So basically what we are going to have is that, so what this means is that we can take the cube root of the entire equation. So we will have r dash cube, and we will take the cube root of this, and that will be equal to the cube root of 3r the whole cube. So basically what we are going to get is r dash is equal to 3r, because the cube root and the cube will cancel each other. So the cube root of r dash cube is r dash, and the cube root of 3r cube is simply 3r. So we have the relationship between the radius of the large sphere and the radius of each of the small spheres, and clearly we see that the radius of the large sphere is 3 times the radius of the small sphere. So r dash is the radius of the large sphere and r is the radius of the small sphere, and we have the relationship that the radius of the large sphere r dash is equal to 3 times the radius of the small sphere, which is 3r. So r dash is equal to 3r. So we have the value for the radius of the large sphere, which is the new bigger sphere that is built after melting all the 27 smaller spheres. So we'll just continue writing that on the subsequent page here. So we have r dash is equal to 3r. So that means the radius of the new sphere is 3 times the radius of the small spheres. So therefore the radius of the new sphere is r dash, which is equal to 3 times the radius of the small sphere, which is 3r. So r dash is equal to 3r is the radius of the new sphere. The second part of the question is we are asked to find the ratio of the surface area of the small sphere and the surface area of the new larger sphere. So surface area of the small sphere, let's write that down. Surface area of small sphere, which we denote as S, is 4 pi r square, because the radius of the small sphere is r. That is what we have taken here. The radius of the small sphere is r, as we have mentioned here also. The radius of the small sphere is small r here. So the surface area of the small sphere is 4 pi r square. Similarly, the surface area of the new sphere or the larger sphere is going to be which we denote as S dash, is going to be 4 pi r dash square, because the radius of the larger sphere or the new sphere is r dash. So we have taken that as r dash. So in the formula for the radius, we will substitute r dash for the value of the radius. So it's 4 pi r dash squared. But we know that r dash is 3 times r. So we can substitute the value of r dash. And so we write, since r dash equals 3r, so we will get the surface area of the large sphere S dash as 4 pi r dash square, which is 4 pi r dash is nothing but 3r square. So we get 4 pi into 9r square. Okay, so that's the surface area of the large sphere, and we have to find the ratio of S to S dash. So S divided by S dash is going to be 4 pi r square divided by 4 pi into 9r square. So we'll have a lot of things cancelling out here. So the 4 and 4, pi and pi, r square and r square will cancel out. So what we are left with is simply 1 on the numerator and 9 on the denominator. So that means the ratio of S to S dash is 1:9. So ratio S is to S dash is equal to 1:9. So the ratio of the surface area of the small sphere, which is S, to the surface area of the new larger sphere, which is S dash, is 1:9. That means the new larger sphere has a surface area which is 9 times the surface area of each of the 27 small spheres. Okay, so we have solved this again by using the information that was given in the question. Again, many of the students have the difficulty that there is no value given for any of these parameters. If the values are not given, Just keep the variables as they are, put in the formula and apply the information given to us. Okay, the most important part for this particular question is that you have to realize that and apply the fact that the volume of the single large sphere is going to be the same of the volume as the volume of all the 27 small spheres, because it is the 27 small spheres which are being melted and formed into a single large sphere. Therefore, the volume of the material in the 27 small spheres and the volume of the material in the single large sphere must be equal. So we equate those two volumes and then substitute the formulae for the volumes of the spheres by using the appropriate notation for the radius. So the radius for the large sphere we have taken as r dash, and the radius for the small sphere as r, and then from that we get a relationship between r dash and r, and we obtain the radius of the new sphere in terms of the radius of the smaller spheres. Okay, so the r dash value, the radius of the new sphere, is 3 times r. We don't get a number here, but we get a general expression in terms of the relationship between the radius of the new sphere and the radius of the smaller spheres. Okay, so the new sphere has a radius which is 3 times the radius of the smaller spheres, and then we use that information in calculating the surface areas of the two spheres by applying the appropriate value of the radius in the surface area formula, and then we take the ratio of those two surface areas and we get that ratio as 1:9. So basically, as I said, the ratio of the surface area of the small sphere to the large sphere is 1:9. In other words, the large sphere has a surface area which is 9 times the surface area of the smaller spheres. Okay, so that is the solution to this problem. And finally, we have just one more question in this exercise, which is question number 10. And what is in this question? We are given that there is a capsule of medicine which is in the shape of a sphere of a certain diameter, which is 3.5 millimeter. How much medicine is needed to fill the capsule? Again, how much liquid is contained, or how much air is contained in the shape, or how much of some material is needed to fill in the space. All these are indirect ways of asking what is the volume of that particular shape. And since the shape is given as a sphere, all we have to do is simply calculate the volume of the spherical capsule. So volume of the capsule, because it's a sphere, is going to be 4/3 pi r cube, and that is all we have to calculate here. So volume of spherical capsule is 4/3 pi r cube. We are given the diameter, so from the diameter we can calculate what is the radius. So given diameter d equals 3.5 millimeter, therefore radius r is going to be half of the diameter, which is d/2, which is 3.5 divided by 2 millimeter. And just to keep our calculations without the decimal, we just multiply the numerator and denominator by 10. So 3.5 into 10 we will get as 35, and 2 into 10 we will get it as 20. So that's 35 divided by 20 millimeter. It's the same thing. 35 divided by 20 or 3.5 divided by 2, both will give us an answer of 1.75 millimeter. Okay, so the radius is basically 3.5 divided by 2, which we have simply represented without the decimal as 35 divided by 20 by multiplying both the numerator and the denominator with the same factor of 10. Okay, so that's 35 by 20 millimeter, and we substitute in the formula for the volume the value of this radius. So the volume equals 4/3. Pi is 22/7 into r cube, which is 35/20 multiplied 3 times, right? So 35/20 into 35/20 into 35/20. So when we simplify this expression, we will get the volume of the spherical capsule, which is the amount of medicine that is needed to fill in this capsule. So when we simplify this, first of the things that we can do is the 7 here goes into this 5 times. 7 5s is 35. The 5 here goes into one of these 20 4 times, and then we have this 4 cancelling out with this 4, so we are left with 22 into 35 into 35 divided by 20 into 20 into 3. So what is remaining here is 22 into 35 into 35 divided by 3 into 20 into 20. Again, we can simplify further since we have 20 and 35. These are all we can simplify them using 5. 5 goes into 24 times, 5 goes into 35 7 times. So let's do that as well. So we will have 5 going into 24 times, and 5 goes into 35 7 times. Similarly, we have 5 going into 24 times, and 5 goes into 35 7 times. So we end up getting 22 into 7, which is 49, divided by 3 into 4 into 4. That is 4 4s are 16 into 3 48. So when we simplify this further, we get the value as 22.45 833. So that's, we have to make this division. 22.45833 millimeter cube. Okay, so the volume is in millimeter cube because the diameter and hence the radius is given in millimeters, so therefore the volume is also going to be in millimeter cube. So it's 22 into 49 divided by 48, so which is 22.45833 millimeter cube, which is the volume of the medicine that is needed to fill in the capsule. Okay, so that's the answer for this question. So that brings us to the end of this particular chapter on surface areas and volumes, and we have solved all the exercise problems from this chapter in this video and in the previous videos. And after this we will move on to the next chapter, which is on statistics, in the next video.